Hello students, welcome back to your lab sessions. So we have completed with experiment number 1 of your part A, that is on network simulator. Now let us see what second experiment of your network simulator have it for you. So the problem statement, the second experiment tells implement transmission of ping message or trace route over the network topology consisting of 6 nodes and find the number of packets dropped due to congestion. So here, as the problem statement tells, we will construct a network consisting of 6 nodes and we will be sending a ping message. We will identify the number of packets dropped. Now here we have two terminologies, that is ping message and trace route. So let us first learn what is this ping message and why ping message is all about, and then we will see the expected output. Finally, we will have a walkthrough to the program. So let us check with your ping message. So what is a ping message? To abbreviate it, it is a packet internet grouper. So why do we use a ping message? Ping message in network is usually used for diagnostic and troubleshooting purpose. Now what is this diagnostic and troubleshooting purpose? Now ping message gives me a provision to check whether the nodes in the network are connected and are healthy. Now what do I mean they are connected and healthy? Now I have a set of nodes that is connected. How do I ensure all the nodes are working? There could be a possibility at some point of the time there could be a node failed. Now there are some mechanisms where a master node notifies if it is not there. If I have to check if all the nodes connected in the network are still working, or if there is any node that I could be doing that by the ping. Now how does a ping work? And how are we invoking a ping message? A ping message is invoked using your Internet Control Message Protocol. So, what does the protocol do? It sends a echo request message to a specified IP address or the destination node. If the destination node is reachable, if the destination node has not failed, the destination node will be sending an echo reply message. So if we are able to get that echo reply message, it indicates that yes, the node has not failed, but there are various other parameters that we could look to. One of the important parameter that is also used as a part of your program, that is your RTT, that is round trip time. So now I said we send an echo message, request message, and we get the reply message back. If the node is working, I am getting my reply message, but if the reply message takes too long, it indicates that the network's performance is poor. There is some latency that is added. There would be some congestion why there is a delay in the network. So these are some of the parameters that we could measure upon. So ping command usually outputs your round trip time. Now let us see what is this round trip time. So as told, it is a time that is taken for a message to reach the destination and again to reach back the source. It is usually measured in milliseconds. So, what is the amount of time it takes for the packet to reach from the source to the destination? That is the request message, and the reply message that is reaching back to the origin or to the source. So if the round trip time is large, it indicates that there is some congestion or there is some issue in the network. So this is one metric that allows us to analyze the performance of the network. There is another term that is there in the question which says ping message or trace route. Trace route is again another mechanism which is used to troubleshoot the network or identify if there is any issue or problem with the network. The question says you could identify it either with the ping message or with the trace route. So in this program, we will be using a mechanism of your ping message to identify if there is an issue and how many packets will be dropped and what could be the round time, when is the round time larger. Now let us see what is the expected output. So firstly, this is your NAM file or the animation file that will be generated. So as it is told, we need 6 nodes: node 0, node 1, node 2, node 3, node 5. Node 4 is in the center. So we are creating a type of star topology where we are having node 4 in the center, and all other node 0, 1, 2, 3, 5 are going to send messages to node 4, and at some point of time there would be a congestion that will be created where node 4 is not able to respond, and it could drop a few packets. So after certain duration of time, you can see the packet drop that happens at node 4, and at regular interval of time all other nodes around will be sending a ping message to node 4. So as said by the question, we will be calculating the number of packets dropped using the awk file, and which is going to work on your trace file. So we will see that in the code. The next thing that we have is about calculating your round trip time. So you can see here the node number, from which node to which node, and what is the round trip time. That is, if I take the very first statement, node 2 to node 3, what is the time that is taken to travel from node 2 to node 3 and back to node 2? What is the time? It is 5.3 millisecond. You can also see another statement, node 0 to node 5. So the time that is taken to travel from node 0 to node 5 and back to node 0. Round trip, I mean, it is from source to the destination and again back to the source. So you can see here it is taking 404.9 milliseconds. So this is how we will be looking with the round trip time. Now let us have a walkthrough to your code. So having a walkthrough to the code, you have already seen in the previous experiment. So we make the initializations. So here also we do the same, again, as the problem statement tells, we will be sending a ping message with the topology of 6 nodes. So here we start with setting the network simulator. So we create an object instance of that with the variable name ns, and we have your animation file and the trace file all set, and then we will start with the creation of the node. So here we have to create 6 nodes, so we are doing the same. So we have node 0, node 1, node 2, node 3, node 4 and node 5. And we said that node 4 is in the center. So that is what is indicated in this statement, $n4 shape box. So we are placing that node in the center. So to have that node in the center is where we are using that statement. Now that we have created the nodes, the next thing that we do is to establish the link. Now here I am establishing the link. I have shown it to you even in the topology there as well. So to establish the link, what do I say? What are the things that I have? I have your ns, the object, and then the type of link, that is duplex, and the node 1, node 2, the bandwidth, the delay, and the queue type. And the queue type here we have used is drop tail. And students, please be careful with the uppercase and lower cases that you will have to use. So we have told you that every node is connected to node 4. You can see that evidently here. Node 0 is connected to node 4, node 1 connected to node 4, node 2, node 3, and as well as node 5. All of it is connected to your node 4. The next thing that we do is, now we have created the nodes, we have established the link between the nodes. Now we have to create a ping agent. Now we are representing the ping agent by P1, P2, P3 and so on. So to create a ping agent, we specify the packet size and the interval and to which node it is referring to. So I am creating the ping agent P1 for the node 0 and P2 for node 1, and we have P3 for node 2, and we have ping agent P4 for node 3. I am not creating a ping agent for node 4. I said you node 4 will be in the center and all the nodes around that will be sending a ping message to node 4. So here we are not creating the ping agent for that. So you can see here node 3 I have created a ping agent P4, and then node 5 we have a ping agent P5. We are not creating it for node 4. And here we are setting the queue limit for some of the links. So we have used a queue type to be drop tail, and the maximum limit for drop tail is 10, and we are setting the limit for the link between node 0 to node 4 and has the limit to be 4, and node 2 to node 4 the limit to be 3, and node 4 to node 5 the limit to be 2. The most important procedure is your receive procedure that we are writing here. So once the packet once the ping agent is receiving a ping reply, then the control will enter this block of the code and print the command using your puts. Puts is very similar to your print, as we use the print statement and it prints it on the terminal. So here we have the puts. which is going to print it on the terminal. So there are two parameters that is supplied here. One is from and the other one is RTT. The two parameters supplied to the receive procedure is from and the RTT. The from is the from node and RTT is the round trip time. So here the node, we print the node ID from which it is received and from, and you have dollar from here. So I have already shown you in the expected output. So from which node to which node and what is the round trip time will be generated by this particular function. And here we also have, you can see here, ns connect p1 to p5 and p3 to p4. We are establishing a virtual connection between the uh, ping agents. And finally we have the finish procedure. So in the finish procedure we close and we declare the global objects and also execute your NAM procedure and finally exit. So for your NAM, for the animation interval of time for your NAM file, so at what interval of time do you want to send the message? So we are starting with the interval 0.1, 0.2, 0.3. It goes on up to 2.9. You can see here. So up to 2.9 we have ping agent 1 that is sending the message, and then we have ping agent 3 that is sending the message. So again we start with 0.1 and again that goes up to 1. 0.1 and here again it's stopping at 1.5 and at finally at 3 we are finishing. This is one set. I want you to experiment with the different ping agents and different intervals of time with increasing and decreasing it. And then finally we have our script file to extract the number of packets dropped. In the last experiment, in the last video, it is already described about your trace file, what are the attributes in the trace file. So the very first column that we have, type identified, and if the type identified is D, so the very first column, the type identified is D, it indicates the packet drop. So we are increasing the counter whenever we identify the packet drop. So I'm using a counter variable C. So this will give me the number of packets dropped. So as already told, we calculate the number of packets dropped. We have node 4 in the center and all the nodes surrounded, and each node we are establishing a duplex link and the type is drop tail. So when I indicate the queue type to be drop tail, it indicates that the packet drop happens at the destination. So here the destination for all the nodes is your node 4. So you can see after a point of time, when we have all the senders sending the ping message to when all other nodes are bombarding with the ping message, at a particular point of time node 4 will be congested and it will not be able to reply, and you can see the packet drop happens at node 4, and eventually you can see the round trip time. So this is about your second experiment. Thank you, students.